Imagine the only thing you know about life is doing 1,000 hours of house chores. That's the entire life of Neo. 1X announced that you can buy Neo today, and everybody is talking about that. But how did humanoid feature become so real? And how did robotics improve this much? Actually, it all comes down to transformers. I mean the transformers that are the building blocks of modern LLMs. For a quick recap, transformers are the model architecture announced in 2017 that introduced the attention mechanism, which finally allowed AI systems to understand long-range relationships in data, basically which parts of the input matter to which other parts. For Neo, this model type is called VLA. But to understand what VLA is, let's start from LLMs. So when we talk about a model like ChatGPT, we write a text and we get a text back. LLMs technically take sequences of text, turn them into embeddings, process them through transformer, and predict the next token based on the entire context. You might think nowadays we can also send an image to GPT as well. And yes, these are called VLMs. VLMs actually follow the same logic as LLMs. Both vision and text turn into embeddings and flow through the transformer. The model uses this shared space to predict the next language token based on the image and the text. So we don't have any output regarding the physical space. And that's where VLA comes into the action. And the inputs are the image, the text, and the robot's own body state. All of these become embeddings and get processed by the same transformer backbone, just like in LLMs and VLMs. And on top of this backbone, there is an action generation head. In some models, it's a diffusion flow matching model. In others, it's a simpler MLP head, which takes this latent representation and turns it into a sequence of low-level actions. And for Neo, this VLA is called Redwood AI. Now that we have a general idea of how VLAs work, let's see what's going on in Neo's mind while it works. So imagine you both Neo and you're watching Neo's POV. While Neo is doing the laundry, the VLA model works in the background. With 1X Neocortex powered by NVIDIA Jetson Thor inside, we know that Redwood AI can do inference locally. But when it comes to training on new tasks, I'm not sure if it will be processed locally or by a more powerful computer from 1X's cluster of GPUs. So back to the POV, here Neo gets the position of joints, the task, and the video that you see, which are converted into embeddings. Then all embeddings pass through multiple transformer blocks, creating a single latent representation of that exact moment. Afterward, this representation goes through a diffusion policy network, which belongs to the same family of diffusion models used by image generators like Stable Diffusion or Midjourney. But here, instead of predicting the next motion outright, it starts with noise and gradually denoises it into a smooth, human-like action. This allows Neo to produce stable natural movements, choosing the right hand, right path, and right grasp. You might actually think, if this model pipeline is working, why do they still need teleoperation? Here what comes the most important factor into the game: home. Neo is a humanoid robot that is built to work in homes. And home is a place where the same condition almost never happens again. For example, compared to a warehouse or a factory, in houses everything changes frequently. Even the natural lighting changes the scene. So, to truly generalize, Neo must first gather data from different houses, for example, your house, guided by human operators. Would you be okay with Neo in your home?